Hello, this is Mrs. Ward, and I am going to go over the cryptology and matrix student activity for the TI Inspire. So we want you to be comfortable using your calculators for the project that we're going to do next time we see you in class. So cryptology is the science of developing a code to encode and decode messages, and this was first discovered in the early 1900s. And they use matrices, really large matrices, to code and decode a message. So what we're going to do is we're going to kind of scale that down. We are going to code and decode with a 2x2 matrix, and just to show you the process, and then we'll show you what we're going to do in class. So if I have a message, and let's say the message that I want to send across the world, and I don't want anyone else to know what I'm sending, is let's say the message is system. And so what I'm going to do is I am going to set each letter up with a number. So you will be given this chart that links A to 1, B to 2, and so on and so forth. And so when I get this message system, I'm going to look for S, and S is 19, and that's how we get that 19. Y is 25, that's how I get that 25. The S again is 19, the T is 20, the E is 5, and the M is 13. So that's how I get that 19, 25, 19, 25, and 13. Now the reason why they wrote it as a matrix in that particular order, a 3x2, is because I just said we're going to use a 2x2 for our encoding matrix. So when I code the matrix, when I code the message, I'm going to use an encoding matrix. And I just said I'm going to do a 2x2, but remember, in order to multiply, this number has to match the number of the other matrix. So this other matrix has to have 2 columns. Then since I have 1, 2, 3, 4, 5, 6 letters, I'm going to do a 3x2, and that way I can multiply, and my answer will be a 3x2. So that's why they wrote the matrix like this. Notice that you just sort of go 19, 25, 19, 25, 13. You go in that order, and you kind of have to go in that order. So that's the reason why I wrote it as a 3x2. Now, I'm picking a matrix that I'm going to use, and this is going to be my encoded matrix. So this is my encoding matrix, and I'm just picking 4, 3, 2, 2. And you have to be careful. You have to be careful that there is an inverse to this matrix. And I know there's an inverse to the matrix because remember last class we found the determinant, and that's when I take that, like sort of cross products. I take the A times D, and I get 8 minus 6. As long as that is not 0, that matrix is good to go. I don't care if the inverse has fractions. I don't care. I just want a matrix that I know I can find the inverse of. So I am going to take the matrix that I have, my message matrix, I should say. I'm going to take my message matrix, and I'm going to multiply it by my encoding matrix. So just to remind you how that goes, I'm going to hit the button next to the 9. I'm going to go to this one that looks like a 3x3 because that is the only one that I can change the dimensions for. Right now it has 3 rows. That's what I want. Oopsie, I just changed it. And now I want to have 2 columns, and then I'm going to hit OK. Then I'm going to type in those numbers just the way they are shown. And then to get out of this matrix, I'm going to hit the right arrow and see how my cursor becomes big and red. That's what I want. I'm going to hit times. And now I'm going to multiply it by 2x2. I could stick with this guy and just change it to the 2x2, or I can use the other one that's already preset as a 2x2. I'm going to do that. And now I'm going to multiply it by my encoding matrix. And when I do that, I get these numbers here: 126, 107, 116, 97, 46, and 41. So I'm going to go back to my paper and write down the product that I got, which is 126, 107, 116, 97, 46, and 41. That's exactly the way it appeared on my calculator. Now it says fill in the numerals for the new message. So I'm going to write 126, 107, 116, 97, 46, and 41. Because if I'm sending this message across the world and I don't want anyone to intercept it or decode it, I don't even want to give them a hint as to what size matrix I use to code it. So you're just going to write a long list of the numbers. One thing you should notice is that these numbers are not between 0 and 26, and they will not be between 0 and 26. When I go to write my original my messaging matrix, those numbers have to be between 0 and 26 because they're matching up to letters. But when I multiply it by that encoding matrix, all bets are off. I can have large numbers like these ones that are well over 100, or I can even have negative numbers, and that's fine. I do want to also point out that if your matrix, your message happens to be an odd number of characters, so let's say you have 9 letters instead of 8 or 10, you're going to have to fill in with zeros. And that 0, if you go back to your chart, that 0 just means a blank spot. So if you have an extra spot that you're not going to use, you're still going to have to add that row, but you're going to fill in with a 0 if needed. So now the next thing it's going to tell me is that it's going to help me try and figure out the inverse of this matrix that I used. So this matrix that I used was the 4, 3, 2, 2. To find the inverse, remember this is the pattern that we learned last time in class where I take that determinant, which is that AD minus BC. Remember that AD minus BC. So I'm going to take 4 times 2, which is 8, minus 3 times 2, which is 6, and I'm going to get 2. And we already did that earlier to show that it was not 0. Then I'm going to multiply by the reciprocal of that. So what they want is they want me to put the 2 here. That is the determinant. Then remember when you're finding the inverse, some things happen to your original matrix. The A and the D switch places, which means that the 4 and the 2 will switch places. So the 2 will come here, the 4 will go here. And then these two, the B and the C, will change signs. So if they're positive, they become negative. If they're negative, they become positive. Now I'm multiplying each one of these elements by 1/2. And I'm going to get 1, negative 3/2, negative 1, 2. And that is going to be my decoding matrix. Now, just to be clear, we're going to verify that those two are inverses. So the directions say test the decoding matrix to verify that these matrices are inverses. When you multiply a matrix by its inverse in either direction, their product will be the identity matrix. Just to remind you, that identity matrix is that 1, 0, 0, 1, if I'm talking about a 2 by 2. Type the appropriate entries into the matrix given on page, well, we don't have to do that. We're going to do my first matrix, the one that they gave me, which was 4, 3, 2, 2, and then multiply it by the inverse that I just found, and I'm going to go to my calculator and multiply those two. And if I'm having a good day, and if I found the inverse correctly, I'm going to get this identity matrix as the answer. So let's see if it works. So I'm going to multiply. I'm going to use the 2 by 2. 4, 3, 2, 2. I got out my matrix, then I'm going to hit times, do another 2 by 2, and now I'm going to type in my inverse that I just found, which is 1, negative 3/2, negative 1. And when I hit enter, I get that 1, 0, 0, 1. Then if I read the directions, it wants me to do it in either direction because remember the commutative property for multiplication does not exist in matrices. In other words, the order that I multiply a matrix in matters, but for inverses it should not. So we're going to put the decoding matrix here as the first matrix, put the coding message here, and when I multiply those two, I should also get the identity. But we have to verify that, so we're going to multiply it in both directions. So I'm going to take this. I wonder if I should do this because it is my favorite button. And then I'm going to get out. Multiply, oh, whoopsie, not divide, multiply. And when I do, I also get the identity, so I am happy, and I am going to write that down here. So I verified that those two matrices are inverses because when I multiply them in either direction, I get the identity matrix as the product. Then it says multiply the encoded matrix. So the encoded matrix was at 126, 107, 116, 97, 46, and 41. And that's what I got way back here. Way back here. That's where I got those numbers. I'm going to multiply that by my inverse, which I just said was 1, -3 halves, -1, and 2. So when I do that on my calculator, and you know, I may cheat. Let's cheat a little bit. So I'm going to go up and I'm going to grab the coded matrix. And now I'm going to multiply it by my inverse. And that just saved me the trouble of typing that all in again, which is fine. And when I do that, I get 19, 25, 19, 25, and 13, which should sound familiar to you because that's what we started off with. But I'm going to have 19, 25, 19, 25, and 13. So now I'm going to write them in a straight line, 19, 25, 19, 25, and 13. And then I'm going to go back to the chart that was given to me at the beginning, so this chart here, and I'm going to decode. So I see 19, 19 is the letter S. I see 25, so I'm going the opposite way. I'm finding the number first, and then I'm finding the letter. And when I do all this, I should end up with system, which was what the original message was. So what we did is we took a message, we changed it into numbers, we multiplied it by an encoding matrix, then we found the inverse of that encoding matrix, and we took the coded message and multiplied it by the decoding matrix to find the original message again. Boy, that's really bad handwriting. So let's try one again. So it says decode the message 18, 27, 51. So you can read the numbers, all those, which was encoded with the matrix 2, 3, 3, 5. So when I count here, I'm going to, this is a 2 by 2 that this matrix C here is a 2 by 2. So I'm only going to have 2 columns. So if I start writing these numbers, I'm going to start 18, 27, can only have 2 columns, 51, 81. See what I'm doing? I'm just going along that list of numbers and writing them in the matrix. 37, 58, 60, 100, 18, 27. Keep on going. 85, 137. 59, 93, 51, 79. So I'm lucky that I ended with an even number, and I have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8 by 2. So I want to come up with an 8 by 2 document, and those are the directions that they're showing you down below, which we've done this a lot of times already. So I am going to take this, I am going to hit the button here. I'm not following the directions, and I'm going to go here. I'm going to hit enter, and then I want 8 rows, so I'm going to change this to 8. I want here, I'm going to change to 2 columns, and I'm going to hit OK. Then I'm going to type in those numbers that I just wrote, and I should have put these I should have written right here. So we'll go do that in a second. So, well, let's do it now. So these are the numbers here. So 18, 27, 51, 87, 81, sorry, 81. I can't even read my own handwriting. 37, 58, 60, 118, 27, 85, 137, 59, 93, 51, 79. Now I'm going to multiply it by the decoding matrix. So I'm going to go back here, and this is the matrix that they used to code it. So the matrix they used to code it was 2, why can I not find it? They used 2, 3, 3, 5. So now I'm going to find the inverse of that matrix. So I'm going to take 2 times 5 and get 10 minus 3 times 3, which is 9, and that's going to be 1. So to find the inverse, I'm going to multiply by the reciprocal. So I'm going to multiply by 1 over 1, which is 1. And then remember, these two switch places. So the 5 will come here, the 2 will go here. And then the signs on the 3's will change. So they both were positive, so now they're both going to be negative. So this is going to be my decoding matrix, is 5, -3, -3, 2. So now I'm going to multiply those two matrices together. So I already put in the one matrix here. Oh, no, I did not. So I'm typing those in, hopefully without making a mistake. So I typed them in. I'm getting out of the matrix, and now I'm multiplying it by the decoding matrix, which is that inverse that I just found. And that inverse was 5, -3, -3, 2. And I'm going to get these numbers here. And it says to help you decode the message, write out the numerals from the decoded message. So I'm going to take these numbers, and I'm just going to write them out in a long list, because that's actually going to make it easier for me to decode. So I'm going to write 9, 0, 12, 9, 11, 5, 0, 29, 0, 14, 19, 16, 9, 18, and 5. Now I'm going to bring out my chart, which we will give you the chart. You do not have to memorize that. And you are going to change the letters into, or the numbers into letters. So the 9 is an I, and then I have a space. And then the 12 is an L, I, K, E, space. 20 is T, I, space. The 14 is N, 19 is S, 16 is P, I, R, E. So the message is I like TI inspire. Of course we do. We love our calculators. And so that's how I decode a message. So this is just to help you get a head start, help you figure out what we're going to do next class when we do the project. See you soon.